First of all, you need an account to sign in with your email address and nickname. And when you click register button, it will redirect to the login page. Then enter the email address and the password you just create. You can get the access to the website. Let's take a look of the home page of the website. The top left corner is the search bar, which has an access to the transport for London. You can search the road information, such like A2. It will give you the link that to the TFL. And the top right corner is the alert message center. When you connect your device, once you upload data, it will send you a message. And the left sidebar provides access to manage your vehicles, but you don't have a registered vehicle in the website yet. And if you click the trip rig button, you will see the video and location of all vehicles you registered. Back to homepage, you can build your own connected vehicles. First, you need to enter your vehicle plate and basic information of the vehicle, such like type, brand, and banding an email address when you want to alert remotely. When you finish that, you can see a virtual vehicle in this page. You can delete it or add a new one in this page. For example, we can register a new vehicle with plate which is 710MB and which brand is Raspberry car and banding your email address. So now let's see what we provide to you for connection and details. This is the car you just registered 701. It includes your car's basic informations, and the two charts are examples of real-time data streaming, but the function haven't finished yet, so I use the MOOC data. And the most important thing is the API key that generated by your vehicle plate, which is random and unique. We will use it to upload data safely. I will show you later. In my case, I use a Raspberry Pi to upload the video. And when you run the program, the URL that can receive data is the IP address and the vehicle number. Make sure your device is in the same network with your computer. I use my phone to be a hotspot and check the IP with the ipconfig command. And then log in my Raspberry Pi remotely within the VNC program. So in the example program in Raspberry Pi, I use a Python library named requests to send the post request. There are two things you need to change. One is the URL and the other is the API key of your vehicle. Change the URL to your IP address and the end input your vehicle plate, and copy the API key of your own vehicle. Then we try to upload a video named car MP4, which is produced by the Raspberry Pi camera. Then we go back to our website. You can see an alert message have been upgraded. Click it to see what you just upload. In the trip record page, you can see the video, and also in the car's details page, you can see it too. And I believe you see the object detection bar in the trip rig page. When you choose a video and try, it will automatically start to analyze the video from frame 1. You can see from the pie chart processing frame 1. And but it takes so long if you don't have a powerful GPU. And when you finish refresh the trip rig page, you can see the video just detected. And now let's see my instance of connected vehicles. Um, the autonomous alert vehicle recording Raspberry Pi. Now I will introduce to you the collision detection algorithm and the alert system example with our web server and the Raspberry Pi car. First of all, I made a data set with 4 categories, including 4,000 pieces of data, and each CSV file is a matrix with the size of 48 multiply 8. And the data records the acceleration in 3 directions of the Raspberry Pi car's driving process, and the resultant acceleration and their respective differentials. The 4 categories are the static state of the car, the normal running state of the car, and the static state of the car when the car was hit and when it autonomous driving. In the Raspberry Pi, I use the MPU and 6050 sensor to detect the acceleration when and record it when in different situations. I set a time interrupt of 0.01 second to generate the acceleration data. Because the collision happened within 1 second, our system must handle it very fast, which also means every 0.48 seconds we can classify the state of the car and by the algorithms. And I try the LSTM algorithms, and you can see I set the hidden size to 384, but it seems not really stable. And finally, I try the CNN with 3 hidden layer, and you can see the input is 48 plus 8 data of acceleration, and its differential, and the output is 4 states of the vehicles. So now let's take a look of the result of our algorithms. Well, you can see the LSTM seems not to work very well compared with CNN. And you can see from the picture, finally I got beyond 90% accuracy in testing data set and almost 100% accuracy in the training data. Now we need to deploy our model in Raspberry Pi. You need to install the PyTorch in it before. But anyway, let's see how the Raspberry Pi can detect the collision. Okay, in the same way, we produce the acceleration data within the MPU 60550, and every 0.48 seconds, we put a 48 multiply 8 matrix into our model, and then using the softmax cars to list of top probability of the car state and the category. I using the sum of probability of the car is in accident to detect. If it is bigger than 0.95, it will start to alert. And more importantly, we can adjust it for high sensitivity. Now let's take a look of the result. When you start the collision detector, it will display the state of the car and the probability of the collision. When the car is still, the probability is almost zero. But if someone touch or does something bad to your car, let's see how it will respond. You can see in the left screen when I hit the car. the state change to someone is doing bad to your car, and the probability of collision it become 0 or become 1, then it starts the alert part. So we we log into our website and you can see the alert already there. And now let's see who did it from the video made by Raspberry Car. You can see it records everything before I hit it and after. It is very important for you to check the state of the car before the collision and after it have totally different situation. So using this video, you can see everything. And now you can see I hit the vehicle, and it's still recording for all 10 seconds. And now if the car is running, will the algorithm still work? Focus on the bottom screen. When I click the start button, the car will autonomous running, and the output is the real-time detection. You can see the first time the car nearly rushed into the barrier, but it braked in time. Our result is it have nearly 0.75 probability to have a collision, so it would not stop. Second time is actually rushed into the barrier. You can hear that, and the output is 100% it happened an accident and start alerting. Seems like it does work. And also I bounding my email address to receive the alert from the car remotely. So I can remotely know what happened, and in our website it also can see the alert video and upload just now. You can see to crash in your mobile phones or in our website.